Good afternoon, friends. Welcome back to Brain Sizzlers. In continuation with our previous video, we are yet again going to find an interrelation between percentage savings, percentage expenditure, and percentage income. Obviously, for in this case also, we are going to start with an example. So, we are going to solve as usual the example with the conventional method. When income of a person is increased by 30 percentage and if his expenditure is 80 percentage of his income, what will be his percentage increase in savings when his expenditure drops by 10 percentage? That is how the question goes. So the question primarily asks that when there is a percentage rise in income and there is a simultaneously there is a percentage drop in expenditure, what will be the percentage rise in savings? So it is quite obvious that when income rises and expenditure drops, savings will obviously be increased. We are going to find only that using very conventional method. Let us keep the initial income to be in. Since the expenditure is expressed as 80% of the initial income, initial expenditure will be in times 80 by 100. Now, as the income is increased by 30%, so the revised income will be in plus 30 by 100 times in. Now, the revised expenditure, it has been given that it is being reduced by 10%. So, everything when expressed in terms of initial income, the initial expenditure will be in times 80 by 100. The drop in expenditure will be in times 80 by 100 times 10 by 100 since there is a 10% drop. So finally it comes out to be in times 80 by 100 times 90 by 100. So the revised savings is nothing but revised income minus revised expenditure. Since there is a 30% hike in income, the revised income is obviously in times 130 by 100. And since there is a 10% drop in the initial expenditure from the initial expenditure, the revised expenditure will be in times 80 by 100 times 90 by 100. So when solving this, we will get in times 29 by 50. So the old savings is old income minus old expenditure. We very well know that the old expenditure is 80% of the old income. So solving that, we get old savings is in times 10 by 50. So when the old savings is given a yardstick of 100, the new savings will be found out to be 290. That means there is an outright percentage increase of 190. Now we are quite obvious that solving by this method is quite tedious. So we are going to find a shortcut formula. In fact, we are going to derive the shortcut formula by framing a mathematical relation between increase in percentage income, drop in percentage expenditure, and percentage increase in savings. There is one strong reason why we derive shortcut formulas. That is because when we are trying to derive shortcut formulas, we are creating avenues for furthermore new shortcut formulas which can be used elsewhere in the quantitative aptitude arena. So deriving is of ample importance to us. So let us see the derivation. Let the initial income be in, and if y denotes the increase in percentage of income, the revised income will be I new equal to in plus y by 100 times in. That is given by equation number 1. Now initial expenditure being expressed as some percentage of initial income, namely x. So E in is in times x by 100. Now when the initial expenditure is dropped by z percentage, the revised expenditure, that is E new, will be given as E in minus z by 100 times E in. So our new expenditure will turn out to be E in times 100 minus z by 100. Now the initial savings, as we all know, is nothing but the difference between initial income and initial expenditure. It will be in minus x by 100 times in, given by equation number 3. Now the new savings will be revised income minus revised expenditure. So after solving, it turns out to be this. So this equation is also of quite a huge importance. Okay, when new savings is expressed as a percentage of old savings, so the old savings is given a yardstick of 100. So the new savings will turn out to be, by applying the normal direct proportion logic, we will get the final value to be S new equal to 100 square plus 100 times y minus x plus xz by 100 minus x, where y represents the percentage increase in income, x represents the percentage of income, that is the expenditure, and z represents the percentage drop in expenditure. So the equation 4 is of paramount importance for solving in competitive exams also. Now we will find the percentage rise in savings. So since this is an obvious case of rise in savings, the percentage rise in savings will be the difference between the one given by equation number 4 and 100. So when 100 is subtracted from the expression given in equation 4, we get the final value to be 100y plus xz by 100 minus x. This is the formula for percentage rise in savings. Now with respect to the example which we considered earlier, our percentage increase in savings was 30 as per the example that we considered, and expenditure was expressed as 80% of the income, and there was a 10% drop in expenditure, the revised expenditure. So substituting all these values, we get a percentage rise in savings as 190. So outrightly we can solve this by saving huge time. So I hope this will be quite useful in solving in many of the competitive exams for MBA entrance exams. Thanks a lot for watching. Have a nice day.